This will be a video teaching you how to graph sine, cosine, tangent, cotangent, cosecant, and secant. Let's begin. In order to fully understand how to graph, it's best to start with understanding the equations that you use to graph. So the formula or the basic equation that we use is y equals a sine of bx minus c, or it can also be y equals a cosine bx minus c. There are two things that you should identify in your equation, and that is the amplitude and the period. So the amplitude is half the distance between the maximum and the minimum, and your period is the cycle, or really it's just how long it takes before the graph repeats. And in order to find that, you can take 2 pi divided by your b. I want everyone to do this example problem. It is y equals 3 sine of 2/3 x. And pause the video right now and see if you can identify the amplitude and the period. Alright, so you should have gotten an amplitude of 3 and a period of 3 pi. Now we are going to move on to how to set up a graph. The best way to envision this and get a good idea of what it should be is to think of your unit circle. Imagine that the unit circle is unraveled. So you make it from a circle into a line, and you can see in the visual representation here that we have the unit circle being turned into more of what you would think of as a graph. So I have it as the pi over 2, pi, 3 pi over 2, and 2 pi. The reason that these are the main increments that we are going to use is because those are the points on the graph where your coordinates are whole numbers. It's a lot easier to graph a 1 than it is to graph a square root of 2 over 2. Okay, so now we're going to be looking at the basic equations for sine and cosine graphs, y equals sine of x and y equals cosine of x. The way we're going to graph it is using a chart, just because it's going to make your life a lot easier, especially once you get into a little bit more complicated concepts. When you're setting it up, put your x's on the top, and then as you go down, you keep adding what's in the equation. So for your x's, they're going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. And you'll see that the next part of the chart is sine of x and cosine of x. So you just plug in what your x is at the top and find out what the answer would be. So if you think on your unit circle, sine of 0 is what? 0. So then you just do that all the way down. Pi over 2 is 1, pi is 0, 3 pi over 2 is -1, and 2 pi is 0. You do the exact same thing with the cosine. The numbers that you get from these charts are going to give you your x and y coordinates. The x column are the x's, and the column underneath that, which is sine of x or cosine of x, is what you use to solve for y. So those ones are going to be your y coordinates, and they just correspond with each other. So for your y equals sine of x, it would be 0 and 0, pi over 2 and 1, pi and 0, 3 pi over 2 and -1, and 2 pi and 0. Alright, then you just take those coordinates that you were able to find using the chart and your awesome math skills and plot them onto your graph. So as you can see, we have the sine graph starting at 0, 0, and then at pi over 2 going up to 1, at pi back at 0, at 3 pi over 2 at -1, and at 2 pi you're back to 0. And since we all know that cosine is x and sine is y, they are going to be a little bit different, but the graphing is virtually the same thing. You just plug in and plot those coordinates that you found using your chart. And once you get all of the numbers on there, you can use your pencil or pen to connect all the dots into a nice, beautiful, curvy line to make your graph. And that is how the basic graph is made. Now we're going to be looking at an equation equation that has a number in for your amplitude. What this is going to do is move your graph up and down the y-axis. So in this example, we have y equals 2 sine of x, and in the graph you can see that it goes up to 2 and down to negative 2. So that is the definition of your amplitude, and it's a perfect way to see how it affects your graph. When using your chart to find the numbers for your x and y coordinates, you would simply multiply your final y by the number that you have in for your amplitude. Okay, and now we're going to see what happens when you change the period. So when you're trying to find the period, you just use 2 pi over b. And then when you're getting the divisions for your graph, you can just divide that by 4. So in our example, we have y equals 2 sine of 2x. So your period would then be pi. So if you look at the graph, you can easily see that the period on the graph is pi. So it's very easy to do. Okay, and things do get a little bit more complicated when we bring in something called a phase shift. So the phase shift can be found using c over b, and it is simply the change in a graph either to the left or the right on the x-axis. So in a regular cosine equation, the graph would start at the 0, 1 for the intercept, and a sine would be at 0, 0. But in a phase shift, it changes that a little bit. So if you have a plus c, you will shift to the left, and a minus c, it will shift to the right. Alright, so in this example, our equation is y equals cosine 2x plus pi over 2. Your b is 2x, and your c is a pi over 2. So if you do c over b, it'll end up being pi over 2 times 1/2. That equals pi over 4. So instead of starting at 0, 1 with the cosine, you would start at a pi over 4. In the graph, you can see that that is what they did. It is using whole numbers, but if you think logically, that is where the pi over 4 would be. So that's basically what a phase shift is. It can be confusing because with a phase shift, you can confuse cosine graphs for sine graphs and sine graphs for cosine graphs. So you have to be careful and really look at your equations on these. Now we're going to learn how to graph cosecant and secant. Cosecant and secant are the inverse of sine and cosine. So in order to graph them, you need to know how to graph sine and cosine. And because of the earlier instructions in this video, we all know how to. So for cosecant equations, first graph the equation as a sine equation. And for secant, first graph it as a cosine. For your vertical asymptotes, you need to put a dotted vertical line where sine and cosine equal 0. Now to make the graph cosecant and secant, you simply have to draw a curve on the minimums and maximums of the sine and cosine graphs. So let's go see what an example would look like. So this is a cosecant graph. As you can see, there's a purple sine graph on here. That is the y equals sine of x equation graphed. And the blue represents the cosecant, and it is really just U shapes on the tops and bottoms of the graph to make your cosecant graph. And here is a secant graph, and it is virtually the same exact thing as a cosecant graph. So it is the cosine graph is in yellow, and the red curves on top of the max and mins are your secant graph. Now we will be graphing tangent equations. Tangent is sine over cosine, and because of this, there are opportunities for undefined, and we cannot graph undefined, so we will take care of that. As your x approaches pi over 2, tangent gets closer to positive infinity, and as your x approaches negative pi over 2, your tangent gets closer to negative infinity. So we cannot have undefined tan. That means that your domain cannot equal pi over 2 plus n of a pi, and your range can be all real numbers because your range is y. To find your starting and ending points of your period, just do bx minus c equals negative pi over 2, and bx minus c equals pi over 2. Your x-intercepts are going to be right in the exact middle of the 2 points that you find using the bx minus c method. We will be able to look at a graph so that all of this will make a little bit more sense. So let's jump in and look at one of those. So by looking at the equation, you can know that your period will be 2 pi, and your vertical asymptotes will be negative pi and pi, because that is where your y is undefined. And then you just simply go through your points that you would find using your chart, and it would make this straight up and down line looking curve that goes from the bottom up to the top, and it would be reflected and go from top to bottom if you had a negative a. Alright, and then we have our last one, which is the cotangent graphs of the cotangent equation. These are very similar to tangent graphs. There's just a couple of small differences. Where you run into undefined, again, put a vertical asymptote. Cotangent is cosine over sine, where tangent was sine over cosine. So as x approaches 0, your cotangent is going to approach positive infinity. And as x approaches pi, your cotangent approaches negative infinity. To find your starting and ending points, you can use the same method that you used for tangent, but you're going to be setting the equation equal to different things. So instead of negative pi over 2 and pi over 2, you will set bx minus c to 0 and pi, and these will get you your starting and ending points. And then right in the middle of those starting and ending points, you can find your x-intercepts. And here is the graph for your cotangent equation. Your period is pi, your domain can be all real numbers, and your range goes from negative infinity to positive infinity. And yes, it basically does look like the tangent, but since it is the inverse, it is flipped a little bit, and then if it has a negative a, it would look more like a tangent equation. So those are a little bit tricky if they start to give you a little bit more complicated equations. For these cotangent and tangent graphs, it is easier to do them if you make the same type of chart that we made using our sine and cosine equations. It's the same exact method, just different numbers will be put in, but we don't really have to relearn that. So when trying to do those, I do recommend making a chart. It will make your life easier. Thank you so much for watching my video, and I really hope that it has helped you learn how to graph these equations and turned you into a math expert.